Hey guys, welcome back to a new video. In the last video, we looked into the ring structure and all that of glucose, and that is kind of very important. Like I would suggest you that glucose ring and linear structure and the ribose ring and linear structure, that are very important. And today we're looking into the configuration, the arrangement of monosaccharide on what basis we have got D and L. So what's that? Uh, D sugar. We got two types. And to making it simple, I will making it simple. This is natural. I'm just making it simple for you guys. Uh, very simple. Whatever sugar is found in D form in the structures we learned till now, they're all D sugar. And this can be sugar, can be monosaccharide, D glucose, D galactose. L sugar, I'll be not writing a definition of it. You need to write the definition about by the points which I'm saying. I would indirectly tell you the complete definition, and that is very simple. This is artificial. Artificial. Right. So, what's the difference between them? How is it natural and artificial? So we have learned D sugar. This is natural, and we did look into structures of all that. So that is the normal one. So normal one is D sugar, that is natural, which we are studying. So uh, normal would be artificial when it is mirror image. What does it mean? Like OH and H element changes simply, nothing else. Throughout the whole compound, the arrangement of H and OH and will change, and mirror image will form totally opposite. So this is artificial. Natural, this is in the body, right? Our body can dissociate it, but this is uh, not. If we just take artificial L sugar, the sugar patients do take it, but they feel pain in the joints because that is not digested. Our body is not having that a proper enzyme to digest the L sugar, because the coding sequence or the structure is different, and our body is not handling this structure. But patients are using it for just the taste. Let me tell you the both structures: one, two, three, four, five, and six. Here H2H and making bonds. You need to stop the video and make this D-glucose structure by yourself, because we have learned it, right? uh, we've got this is uh, aldose, so we need to do this is constant in aldose sugar. If you're not understanding what I'm saying, do check my previous videos, because those are very important to understand the structures. We're having bonds on these sides. Okay, so C3 would be different and others would be same. C3 is this, different H on this side, HO on this side. Remember that we can sometimes write OH on this side, but that is actually HO, because oxygen and carbon are making bond, not hydrogen and carbon. Do remember that. Even though I do mistakes sometimes, but I do remember that. This is OH, this is H. All would be the same remaining. We did look into this structure very, trickily. OH and OH, H, We did on the right side we do OH and the left on HO, because on the right side this is direct link between oxygen and hydrogen. So this is D glucose. D glucose. Now we're looking into the L glucose, making it green. 1, 2, 3, 4, 5, 6. This same thing, the topmost things would be the same in any case because they are aldoses, and this would be H2OH constant. Now we have got bonds between them. And here, 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 and here. Now we got C3. We just make a mirror image, like we do over here. Mirror image, mirror image. Just opposite that. Like if you have on C3, the constitution is changed. Like this would be normal on this side, OH and H. On these would be different. Like this is a mirror image. All would get H, and all on that side would get HO. HO, HO. So this is how it works. I do hope that you got the concept. And if you haven't, watch it again. This is L glucose. L glucose. Right. So I do hope that you learned something. Let me check out a picture if it is available. So this is kind of a complex one. uh, this I can show you guys. This is the same thing, and do remember that this thing is these both are isomers to one another, and these are both called enantiomers to each other. This is a good point that let us ask in MCQs, like what are these called? These are called enantiomers to each other, and these are stereoisomers, isomers to one another, and that is also a point. And I do hope that you learn something, and meet you guys in the next video. Till that, goodbye.